So in this video, we're going to pick up where we left off in the last video and make some of these inequalities a little bit more complex. We're going to work on solving compound inequalities. Remember that compound inequalities just means multiple inequalities where they can be connected with the words and or. So we're going to start by working on the and inequalities. And we're going to follow the exact same steps that we've been doing to solve inequalities. There's one difference. When we're working with and inequalities, remember that we can sandwich them together. So we're always going to see them like this. We just need to remember that this now has three parts to the inequality, right? Unlike an equal sign where it splits it into two parts, now, because we have two of these inequality symbols, we actually have three parts to worry about. So whatever we do to one of them, we want to balance it and do it to all three. We're still going to do the flipping of the inequality sign if we multiply or divide by a negative. So let's jump into it. We're going to focus on the middle here and notice that x is being multiplied by 2 and then we're subtracting 1. So we're going to do our Gemma steps backwards, right? We're going to undo things. So we're going to deal with adding and subtracting first, and then any multiplying or dividing second. So I'm going to worry about this minus 1. I'm going to undo that by adding 1, not to one side, not to two sides, but to all three sides of this inequality. So that's a little weird, right? But we're just going to do them piece by piece. So this first piece is now a -6. The middle piece is now a 2x, and the last piece is a 14. Right, not too bad. All right, now we're going to undo this multiplying here with some dividing. So we would divide this by 2, which means we're going to divide this piece and this piece by 2 as well. So we see we have that 3 pieces all being divided by 2. All right, so now we'll simplify a piece at a time. We get -3 less than x in this middle piece and 7 on that last piece. And we've done it. We've got x by itself. We solved for x. When we graph our answer for this one, let's see what that's going to look like. -3 and 7 go on our number line. We don't want to include those values, right? Not equal to that, but we want x to be in between them. So we're going to shade in between. So we really just have one extra piece of the inequality to deal with, but really the steps are identical. Let's just do one more and make sure we're okay with this. All right, so we're going to look at the middle here, and we're going to undo things backwards, order of operations. So I'm going to subtract 4 on all sides. So this now reads -3 less than -3x in the middle, less than equal to, that turns into an 18. All right, next step. Here we would divide by a -3. -3 meaning that we need to do some flipping, right? Okay, so here we go. Do our division. So -3 divided by -3, that's +1. We're going to flip this sign here. All right, in the middle, we have our x. Now we have more inequalities. We're going to flip those as well. Still keep that equals there. And over here, this is going to turn into -6. Now be careful. This is our answer, but it looks kind of backwards, right? Because when we draw the number line for this, -6 belongs over here and 1 belongs over here. Okay, so let's see. We're allowed to equal the -6, so I'll put a closed circle there. And we don't want to equal 1, so an open circle on 1, and x is in between them, so we'll shade in between. It is as simple as that. Okay, so those are and inequalities. Let's do an or inequality next. When we're solving or inequalities, we don't have that sandwiching that happens, so that means we're just going to have to do 2 separate inequalities, which really isn't that bad. Still the same rules if we're going to flip things when we divide by negative or multiply by negative. And when we graph, don't forget we're going to be graphing 2 separate things here. So let's jump into it. Negative 2x plus 8 is greater than or equal to 2. Let's solve that one by subtracting 8 on both sides. That's now a negative 6. And then here I would divide both sides by negative 2. We're dividing by a negative. That means we're going to have to do some flipping here. So we get x is now less than or equal to positive 3. Or now we have to do the other side. Okay, we're going to subtract 8 on both sides. So now I have negative 10 greater than negative 2x. We're going to have to divide by negative again. So divide by negative 2. And I get 5 is, flip this around, less than or equal to x. Okay. Here is my number line. Here is 3. Here is 5. So what does that look like? We want to allow the numbers to be equal to 3, but we want all the values that are less than that as well. So I'm going to shade to the left of 3. Okay, and now for the other piece, we're allowed to equal 5, so I'll close circle on 5, but we want all the values that are greater than 5, so I'll shade to the right of 5. And look at that, it looks just like when we were graphing the OR inequalities in the other video. That looks great. Might as well do one more. Okay, so here, let's see, I would subtract 1 first. So we have 15 less than 5x, and then I would divide both sides by 5. So I get 3. No flipping needed, right? Less than x there. Or, and this looks like the exact same expression, right? So we're going to do the same steps here. So minus 1 makes this a 30, and then divide that by 5. And we would get 6 there. So no flip on that either. So we get x is greater than 3, or x is less than 6. Let's get that on a graph. There's 3, there is 6. Okay, so let's do this first part. Don't include 3, but we want all the numbers bigger than that. That's looking strange, isn't it? We just went through 6. All right, let's do the other one now. X is allowed to equal 6. We've never done that before. But we want all the numbers less than that. I would be shading down here. Ooh, I just filled in that closed circle. And take a look at my number line this time. It looks like every number is shaded in. And that's okay. That can happen. What I am going to do, I'm going to write down that something special happened. I'm going to say that our answer is all real numbers. Now, you don't necessarily understand why I wrote the word real, okay? That's really an Algebra 2 topic. But when the entire line is shaded in, right, that really means it can be any number. Right? All the real numbers are solutions to that. So that can happen sometimes if those ORs overlap with each other. All right.